So I want to talk about that one for sure. And then we'll talk about whatever else you want to talk about here. But I want to talk about that slant asymptote problem because I feel like some of you have forgotten some pretty key concepts that you actually learned in Algebra 2 also. So if you look at this rational thing right here, this is not a question on there, this is, I'm freelancing here. If you look at this thing right here, this is how you determine your horizontal asymptote. You look at the highest power of the variable, in this case it's x squared, and you compare. So here, your horizontal asymptote would be y equals 3/2. Those are also called end behavior asymptotes, okay? Now what if we had this problem? Well now, our highest power, these don't match. And the highest one is on the bottom, which means as x grows, the fraction is going to get smaller. There's no x cubes up here to balance out these, so that horizontal asymptote would be 0. Now, when the top, this is the problem on your paper, when the top is bigger than the bottom, then there's no x cubed on the bottom to balance the top, so the curve just keeps getting bigger and bigger. But the ratio of these two numbers is important. If you did the division, you'd get an x, right? Because you have an x cubed divided by an x squared. So your end behavior asymptote is going to be some kind of a line. Now, the curve is still going to shoot up, but it's going to follow that line as it shoots up. If that was a fourth, and that was a squared, then the end behavior asymptote would be a parabola. Okay? Now, if this is linear, because it's x cubed over x squared, what does that reduce to? Plain x? Y equals x. And then plus whatever. So you didn't technically have to do the division, but if you do the division, you will get the entire asymptote. Here it just asks for the slope. The slope's going to be 1. If this had been 2x cubed over x squared, the slope would be 2, because when you did the division, you get 2x. Does that make sense to everyone? Okay. Now I want to just pop in some quick review, and then we'll go back to what we learned here. Maybe I should do this tomorrow also, or whenever I see you again. If f of 4 is negative 21.3, and f is an odd function, what's f of negative 4? Positive 21.3. Because what does it mean to be odd? It means if you change the sign on the input, you're going to change the sign on the output. There was a problem in our multiple choice where we had an odd function, and the maximum was like at 2, 10 or something. Well, where's the minimum then? Negative 2, negative 10. Change the sign on input, change the sign on output. What's secant by definition? Give me a couple definitions. What's secant? 1 over cosine. Beautiful. Anybody give me another one? What's cosine? X over R. So secant would be R over X. Right? Okay. Unit circle problems here. You guys are actually really good at these, I feel like. What's the sine of pi over 6? 1/2. Tangent negative pi over 3. Tangent. Negative root 3. Because it's root 3 over 2 over 1/2, so it's root 3. Negative and quadrant 4. Cosine 7 pi over 4. Positive root 2 over 2. Very, very good. Alright, what's the sine of 2x?
Was that sine squared?
No,
2
2 sine cosine or cosine sine. The order doesn't matter, you're multiplying. There's only one identity for sine 2x, and that's it. Alright, you guys don't need to be scribbling all this down. It's on your need to know sheet. But we need to know it. Okay? What is cosine x minus y? cosine, cosine, plus sine, sine. There you go. There you go. Awesome. So anytime you have a problem that involves the cosine or sine of something being added or subtracted, at least think about that identity. You may not use it, but at least think about it. It's an option for you. What's 1 plus cotangent squared? What did you say? Cosecant squared. Yep, cosecant. 1 plus cotangent squared is cosecant squared. 1 plus tangent squared is secant squared. All right, properties of logarithms. Here we go. Expand it. What is this? What? 2 log A plus log B minus 3 log C. Now, boys and girls, if this had been a minus, then both of these would be in the denominator, right? If that were a minus and that were a plus, these two are on top and that one's on the bottom. Pay attention, right? Okay. I messed all that up. That's no longer good. Okay, properties of exponents. What are you going to do? There's no calculator. You got to multiply these things together. What are you going to do? Your base will be 5. So 5 squared, x plus 2, times 5 to the negative first, 3x. So we have 5 to the 2x plus 4, multiply, times 5 to the negative 3x. And then what do we do with these? Add them. Not an equation. We're not setting them equal to each other. We're adding them to multiply. We're adding them. So that's going to be 5 to the negative x plus 4. Perfect. Perfect. Okay, quick review. All right, any questions so far? Oh, I know there's one I want to talk about. Did anybody get 17?
Yeah, no.
17, tricky problem. Here's why. 1 plus sine x over cosine x, and we want to find it 0. So I hope you just set it equal to 0. And then, 1 plus sine x equals 0. So sine x equals negative 1, and there's only one place that happens, and that is down here at 3 pi over 2. And that's in my 0 to 2 pi range. Here's the tricky part. Go back to the original problem. What happens in the original problem if you put cosine, if you put 3 pi over 2 in there? What's the cosine of 3 pi over 2? Uh-oh. Can we have a 0 in the bottom? So this problem has no solutions. They don't do that very often, but they did it this time. That is a tricky one. Tricky. All right. I don't know. What else? Are there any others you found? Do we remember how 21 works? That was, they just kind of snuck it into one of the sections and it didn't really fit. They just put it in there. And we want to expand x plus 3y to the 5th. And it looks like we're expanding the whole thing. I mean, it's all written out there. So that means x plus 3y, Xander, x plus 3y, x plus 3y. Okay. Could you multiply it all out and get the answer? Yes, that will chew up a chunk of time. So do that at the very end if that's going to be your plan. But we do have a shorthand way of doing it. Do you remember Pascal's triangle?
Yeah.
So you would need to go to the 5th row. Now Pascal's triangle starts like this. There's the 2nd row. Here's the 3rd row. You know where I'm getting these numbers, right? Then the 4th row. And finally, the fifth row is the one that I want. Okay, so here we are, 1, 5, 10, 10, 5, 1. Those are the numbers that would be in the fifth row. Everybody good so far? Okay, then next to each of these numbers, we have an X and a 3Y. And then tell me about my exponents, the only thing left to do. What?
Is the first one like 5?
On the X,
On the X,
it'll be 5. And then down they go. And then Y's do the same thing the other way. And there you go, guys. That should be an answer. Now, I noticed they didn't even multiply it out. Normally we do, like we figure out that would be 90x cubed y squared. They just left it. So find one that matches. Did you find anything else? As you, yeah, Addie?
You do 22.
Maybe, let's see. Okay, so what I always do, Addie, is I change my problem into rectangular. So I'm gonna graph it rectangularly. This is backwards for me, so I'm gonna think of it like this. And then it is really beneficial to me if I remember that cosine is an even function. If you think about what cosine looks like, right? This is what cosine looks like. It's symmetric about the y-axis, it's even. So what does it mean to be even? It means when you put in a negative, it doesn't change anything. So I'm gonna graph this. If this had been a sine is off. So that negative would have come out here and canceled this negative, if it were sine or tangent. All right, so now I'm gonna graph that thing real quick. I'm gonna look at the whole thing and narrow it in the section I want. So here's my midline. Amplitude is 2, and it's negative. So I'm gonna start down here. There's my cosine curve. Now, I wanna know from pi over 2 to pi. So this part of the graph right here. Pi over 2 to pi. How is the distance between the origin and the points on the curve changing? Remember, this is my origin. So what's happening to those points? They're increasing. Yeah, the distance is increasing. Does that make sense to everybody? All right, so here's what you're gonna do for next time. You're gonna finish the multiple choice. So you're gonna do the calculator and then the calculator part. I don't know how far you got today, but you're gonna finish the rest of the multiple choice. Okay? We'll review again next time on Friday. We'll review again for the what you need to know quiz. Okay.